And now the methods of sets. The way you access the attributes and methods of set is exactly the same way the way you accessed for tuple and list. You use dir. So in this case, when I run this, it gives me all the necessary attributes and methods of set. The important ones are the ones without the underscore. Those are these ones, the last ones. And we'll be studying these ones. If you want to look at the what these functions they do, you can do help. So come over here, comment this line out, and type print help set, and that's gonna print out help for each one of them. So let's look at a few of them. Let's come down and let's look at just this clear one right here. What this one does, it says it removes the all elements from this set. Difference, it returns the difference of two or more set as a new set. All right, so this way you can access the help on each and every inbuilt methods and attributes of your set. Let me comment this line out, uncomment this, and run it again. Okay, now let's suppose that we have a guest. A guest, this is a list. Okay, sorry, a set. This is a set of guest. I print the guest and then I want to add an element to that. So in this case, I'm adding Ravinder to that. I'm adding a member to the guest and then I'm printing guest again. So when you run this, you can see that it says Shamlodia, Chaudhary, Shamlodia, Wagner, Lee. These are my initial before I added. Then I added a guest Ravinder and then I print my guest again. And you can see that Ravinder now has been added over here, right there. You can also remove an element. So this is my guest right here. Print my guest. I remove Lee from the guest. I'm removing this gentleman, and then I'm printing the guest again. When I run this, you can see that Lee is gone now. After I remove the guest, after I remove Lee, and I print my guest again, Lee has gone. What about if you want to combine two sets? Suppose you have two sets of students. One set of students is in the class art, and the other one is in the gym, and you want to know how many who are the people who are in present both in art class and also in the gym class. So what you can do, you can do union, and the way you do union, you can do class art dot union. You can call the union function inbuilt method, and you can specify class gym. That's going to give you the all the elements that are present inside this and this. And by the way, it's not going to contain duplicates. So you can see Bob is over here, Bob is over here, but it's not going to print Bob twice. So this way, when I print this statement, it prints out Charlie, Alice, Bob, Geeta, David, Vicky, Zena. You can also do union using this operator right here, this vertical sign right here. So this is going to union this class with this class, and it prints out the result. And as you can see, is exactly the same result right here. Uh, what if you want to know the intersection? Students that are in both classes. Now, in this case, these are the students that were in arts class and gym class. In this instance, you want to know the students that are present in the art class and also at the same time present in the gym class. So in this case, we want intersection. So let me give you a little pictorial representation. Maybe that will help you understand the difference between these two. So this is a Venn diagram to help you understand this union and this intersection. So in the art class, I have Alice, Charlie, Bob, and Zena right here. In my gym class, which is this right here, I have Bob, Zena, I have David, Geeta, and Vicky. That would be these people right here. Now, when I'm doing union, I'm basically combining the elements of art and gym class. And this is going to give me this element right here. So A, C, B, Z, D, G, V. I'm just using the first letters of the name over here. When I want to do the intersection, that's going to tell me the elements that are present in both art and gym. That would be this people, these group of people right here. Okay, that in that case is going to be Bob and Zena, because Bob and Zena is present both in art and also at the gym. Then there's also a difference. Let me just decrease the size of the screen so maybe it can viewable. Yeah, let me make it a little bit smaller. So now there is something called difference. Difference, what it does, maybe you want to find people, students only in the art class and not in the gym class. So in this case, this is your art class. You want to find people exclusively in the art class but not in the gym class. So you're going to say a you're saying class art, difference, class gym. So in other words, the answer would be A and C, Alice and Charlie. Let me just uncomment this thing out, make the signs a little bigger so this way you can see, and come down over here. All right. So this way, what I'm doing, I'm removing from my class art all the students that are inside the gym class. And so this way, it removes people who are inside the gym class. So you can see Bob is gone. Okay, there's a Bob inside the gym class, so that's taken out. And also, let's see, anybody else? You have Charlie, Alice, Bob, David, Zena. Yeah, Zena is also taken out because Zena is in gym class. So Zena has been taken out. So now you're left with Alice and Charlie. So you can do class art dot difference. That will give you this Charlie and Alice, or you can do class art minus Jim. Likewise, you can do other way around too. You can do uh, like class gym minus class art. So this will give you the students who are only in class gym and not in the art class. And then there is a is disjoint. Is disjoint, it can be used to check if two sets of emails, whether two sets, do they have any common element. So for example, let's say I have an email list from company A, an email list from company B, an email list from company C. These are my email list right here. I want to check if A is disjoint with B. In other words, is there any element? Is A and B, do they are they disjoint? In other words, do they have any element that is in common? Well, in this case, A is disjoint, B comes out to be false because your A and B, they do have common element. You can see that Bob Gmail is over here and Bob Gmail over here in A and B. There's a Bob at hotmail.com, Bob at, let's see, yeah, Bob at this one, Bob at msnmail.com, Bob at msnmail.com. Because these elements, they do have elements in common, so your A is disjoint, B is false. What about A is disjoint C? Well, that is true because A and C are completely disjoint. There is no common element between A and C. You can check actually manually. You can see over here, Geeta yahoomail.com and Bob3 msnmail.com is not present inside this set right here. Uh, you can also use this. One of the interesting application of is disjoint. You can check if there's any scheduling conflict. Suppose you have a meeting time between 10 and 10 to 14. So you have a meeting time at 10 o'clock, 12 o'clock, 13 o'clock, and 14, 14 or 0 time. And then let's say you have another schedule which starts at 14, 15, and 16. Let's say these are your military hours. And then you have a meeting time from 15 to 16, okay? 15, 16, 17. So you want to check if there's any disjoint or if there's any conflict in your meeting schedule. You can do this thing. You can say A dot is disjoint B is going to print true and false depending on whether they have any elements in common. In this case, it says false. In other words, A is disjoint B is false. In other words, A and B, they do have conflict over here. Okay, so this should be false. False. In other words, there are common elements. Okay, and you can check that A and B, if you look over here, there will be some common elements. Let's see. Yeah, 14 right there. There's a 14 and there's a 14. There's a common elements. What about A and C? Is it disjoint? Well, in this case, it says true. So that means there is no common element between A and C. 10, 12, 13, 14, 15, 16, 17. So A and C have no, they do not have any time conflict. Then there is a is subset. It is used to check whether whether one set is part of or is contained or is a subset of another set. Suppose you have a user cart and you want to know if the cart items are a set or are a subset of a non-combo deal. So let's say this is your set. Your A is this right here, and B is this, and let's say your C is this right here. These are three sets. You want to know if B is subset of A. Well, when I run this, the answer is true. In other words, B is subset of A. So if you look at elements of B, all the elements of B are present inside your A. Is it bread and cookie? Bread and cookie. So B is subset of A. What about A is subset of C? Well, is A contained inside C? Let's see. The answer is false because A is not contained inside C. You can see some elements like you can see bread is over here, cookie over here, jam over here, jam over here. What about honey is over here, honey over here, milk? Oh, milk is over there, but I don't see the milk in here. So that tells me that A is not contained inside C. So that's why it prints out false. What about C? Is C subset of A? Well, in this case, it's saying true. That means C is part of A. Let's verify that. In C, you have cookies, jam, honey, bread. Bread, cookies, jam, honey. Yep. Every element over here is present inside A. So C is a subset of A. You can also understand this through a Venn diagram. So in this case, my A consists of bread, cookies, jam, honey, milk. So this is my set A right here: bread, cookies, jam, honey, and milk. This is my A right here. My B consists of bread and cookies. So this B would be just bread and cookies. So I draw a little diagram right here. This is my Venn diagram. What about C? C contains cookies, jam, honey, bread. So C will contain bread, cookie, jam, and honey. So this is my C right here. So you can see now, just by looking at this diagram, that is B is subset of A, is B subset of A, and the answer is yes, true, true. Is A subset of C? Is A subset of C? Well, no, that is not. You can see that it's false. What about C? Is C subset of A? Is C subset of A? The answer is yes, it is. So it comes out to be true. This way you can determine whether one set is a subset of another set.